So hi everybody, and welcome to this Data Science Festival Lunch and Learn. I'm going to talk about how we built data architecture and system integration at Climate-KIC to become a data-driven business. So, so my name is Amélie, and I'm an experienced data and business intelligence lead holding a master's degree in statistics and business intelligence. During the last few years, I have led the data governance and strategy, which is a critical pillar of the business. And I am a firm believer that technology paired with people's understanding and considered use of the data is an enabler leading to success. I've worked in different industries, including advertising, and I'm currently working in the innovation space to tackle climate change, which is great as it's aligned perfectly with my mission, which is fight against climate change. Now, I know that everyone must have heard what is climate change, but let me touch base very briefly on that. So I like sharing this little graph by Ed Haudiquet. So climate change describes a change in the average conditions, such as temperature and rainfall, in a region over a long period of time. So for instance, 20,000 years ago, much of the US was covered in glacier. And in the US today, they have more like a warmer climate and fewer glaciers. So global climate change refers to the average long-term changes over the entire Earth. This includes warming temperatures and changes in precipitation, as well as the effect of the Earth's warming, such as rising sea levels, shrinking mountain glacier, ice melting at a faster rate than usual in Greenland, Antarctica, and the Arctic, and changes in flowers and plants blooming times. So Earth climate has constantly been changing, even long before humans came into the picture. However, scientists have observed unusual changes recently. For instance, Earth's average temperature has been increasing much more quickly than they would expect over the past 150, 170 years. And you can see that live in this graph. And for instance, I've also highlighted here a picture of Alaska in 1941 compared to 2004. You can see that it was a glacier before and now it's just a lake. So there's a lot of factors that contribute to Earth's climate. And scientists agree that Earth has been getting warmer in the past 150 and 100 years due to human activities. So there are certain gases in Earth's atmosphere that block the heat from escaping. So this is called the greenhouse effect. And these gases keep Earth warm, like the glass in a greenhouse keep plants warm. So human activities such as burning fuel for factories, cars, and buses, or changing the natural greenhouse. So those changes cause the atmosphere to trap more heat than it used to, leading to a warmer Earth, which is not really good. So what we do, humans, matters because oceans, lands, air, plants, animal, energy from the sun is all connected and all have an effect on one another. So the combined effect of all these things give us our global climate. So in other words, Earth's climate functions like a one big connected system, and we are part of it. So staying within a 2 degrees rise in warming demands radical changes to the way we use natural resources, materials, and energy, to our environment, our mobility, or the way we grow and consume food. So what you do matters, and that is what we're trying to tackle at Climate-KIC. So Climate-KIC, the company I work for, is a knowledge and innovation community, KIC, which has been established and funded by the European Institution of Innovation and Technology, EIT, in 2010. Our purpose is to tackle climate change through innovation. We are Europe's largest public-private partnership with this purpose, and a growing pan-European community of diverse organizations united by a commitment to direct the power of creativity and human ingenuity at the climate change challenge. So we bring together large and small companies, scientific institutions, and universities city authorities and other public bodies, startups and students. We bring them all together. So we have over 370 partners across more than 25 countries. And we work on innovation to mitigate climate change and to adapt its unavoidable impacts. So our mission is to catalyze systemic change for climate action through innovation in areas where human activity, Earth, have critical impact on greenhouse gas emissions, like cities, land use, materials, and finance. And we want to create a climate resilience community. So that being said, when I joined Climate-KIC in 2018, a couple of years ago, when I started, we were starting to build a data architecture, specifically for collection data on our innovation projects, flagship ecosystems, education program, and our financials. The aim was to create a clear and stable data structure to support the implementation of our activities. So that meant liaising with the different teams at EIT Climate-KIC to identify and understand the needs of the different teams. And we had a lot of different teams. So this transition has introduced business intelligence capabilities into the organization and thereby enhanced decision-making from our data. Although when we started, the first challenge was the state of the data, like find the data and understand it. There was no source of truth, and we were using multiple current and historical systems. There was too much data collected in different systems, in different formats. So the main challenges was to leverage the existing data to become a data-driven business. Now, the first thing to do was to choose the right tools. There are many solutions out there, and the chances that all of us in this Zoom meeting are using the same tools is pretty much inexistent, right? So let's kick off with a poll. Yeah, you can see it on your screen. So if you could tell me what is your favorite data warehouse or database, have listed a couple of options. If your favorite one is not there, can you please specify in the chat which one? I'm very keen to know what you like to use and why. So let's wait a little bit more for your responses. I can see some people commenting in the chat. It's great. All right. So here are the results. AWS for 38% of you. Great, and others. So I'll dig into your responses in the chat. Thank you for contributing to this poll. Well, at Climate-KIC, we have opted both for an ETL software to move and manipulate the data, as well as a data warehouse. So let me walk you through our preferred option. Here we go. So we choose Talend as an ETL software. Talend is a cloud-based software specialized in data integration and used to perform the extract, transform, and load ETL process. So that type of data integration connects and blends data from different EIT Climate-KIC's data sources, basically. So once the connection is established, we can create data preparation jobs, and we define them and execute them to transform the ingested data in order to harmonize and prevent missing or mistaken values. So for instance, to give you a very specific example, because we were using different platforms, some of them, it was specified UK as a country, and in another system, it was specified United Kingdom. So the whole point of having Talend is as well to help us curate that data and show both of those values, the same values, for instance, United Kingdom. So the other good thing about Talend is that it allows us to schedule jobs as well as extend the base of data integration functionality, which with advanced data cleansing and business process management workflow. Now, we also use a data warehouse, and at Climate-KIC, we really like Snowflake. So Snowflake is a cloud-based data warehouse that enables us to store and manipulate and shape the data for an easy access. The data in Snowflake is represented as tables that can be queried and modified through the standard SQL interfaces. So each table view belongs to a schema, which in turn belongs to a database. Snowflake is very good as well for continuous data protection. They have a lot of features that help you protect your data against human error, malicious acts, and software or hardware failures. So you can track the data transformation and reduces the risk of error in the manipulation of the data. Right, so once we had chosen the tools we felt were right for us and our data, we had to start thinking of the data architecture itself and how our systems were going to be integrated. So I would like to emphasize that building a data architecture requires some thinking. One of the key aspects is to set up the right principles and practices to ensure high quality through the complete life cycle of your data. So that is called data governance. So because data is becoming the core corporate asset that will determine the success of the business, you can only exploit your data assets and do a successful digital transformation if you're able to govern your data. So this means that it is imperative to deploy a data governance framework that fits with your organization and your future business objectives and business models. So that framework must control the data standards needed for this journey and delegate the required roles and responsibility within the organization and in relation to the business ecosystems where your company operates. So well-managed data governance framework, it's very exciting, will probably underpin the business transformation toward like operating in a digital platform at many levels. So for instance, you have for the top management, this will ensure the oversight of corporate data assets, their value and their impact in the changing business operation and market opportunities. For finance, this will safeguard consistent and accurate reporting. For sales and marketing, this will enable trustworthy insights into customer preferences and behavior. For procurement and supply chain management, this will fortify cost reduction and operational efficiency initiatives. And for production, this will essentially deploy automation. And finally, for legal and compliance, this will be the only way to meet increasing regulation requirements, which is quite important, even more if we talk about GDPR, for instance. So if you manage very well your data, you shouldn't have any issues with GDPR. So what data governance means is better, leaner, cleaner data, which means better analytics, which means better business decisions, which means better business results, better market positions, mind share in your space, reputation, and a better profit margin, which any business would want. So now I'm going to dig a little bit more on how that was translated at Climate-KIC. So as mentioned before, we have different systems, which I have simplified here. We have our grant management platform, we have our CRM, Salesforce, we have different finance tools and different HR tools. And how that works? Well, of course, we use our ETL software, Talend, which extracts the data from those different systems. So the data is moved to a staging area, which I've represented with those green dots. And each of those blue arrows represent one or multiple Talend jobs in the backend. So those Talend jobs, as well as extracting the data, they also load the data in Snowflake in our ingestion layers. So I'll talk a little bit furthermore about those different data layers that you can see in Snowflake in a couple of minutes. But what I also want to say is that Talend, with these purple arrows, will also allow us to build some custom jobs to transform the data and curate the data. So as per my example mentioned previously, when we had UK and United Kingdom, this is where we'll decide, well, for any values that is UK or United Kingdom, we want it to be shown as United Kingdom. We also have some of that data once it's curated, and in our case, that is moving one of our source systems. So here we would have some of our grant management data going in the ingestion layer, being transformed and harmonized, and then brought back into our CRM, Salesforce. So that will allow us to track the activity for each project and partner and better manage our relationship with our partners. So once we have curated and aggregated our data in those different data layers, we are ready to analyze and visualize our data. So we use different tools, which are Tableau, our main BI tool. We have multiple dashboards that have been created since to enhance decision-making in our business. So those dashboards in Tableau allow us to have a trusted view of our full portfolio of activities and enables us and our senior management to make decisions based on that. We also use Power BI this is mainly for our local teams. So in each local team, we sort of have some data guru, which will have access to specific data set in Snowflake in the consumption layer. And again, I'll talk further about roles and permissions later on. And so they'll be able to create their own Power BI dashboards and do their own analysis. So sort of a self-service. And finally, thanks to Snowflake Haudiquet driver, we can connect directly to Excel. For instance, we have our finance teams that perform some planning analysis and they want some raw data. They need the raw data. So this is absolutely great for them. So now that I've walked you through our system map, I would like to talk a little bit more about Snowflake and the different data layer we have in place there. So first of all, to build our data infrastructure in Snowflake, we have the ingestion layer. This is where we have all the raw data as it is in our different systems. No change are made in the data structure or the format at that point. It's purely the raw data. Then we have the curation layer. So this is where Talend performs some data changes, cleansing and restructure to harmonize the data. So it looks good and clean, what we want, right? We also have a calculation layer, which is mainly used for our finance data. This is where we consolidate and calculate some different metrics and specifically for our finance data. And then we have the consumption layer, which is where we create views that are ready to be analyzed or connected in our different tools. So Tableau, Power BI, and Excel would be connected directly to this layer. This is where people at Climate-KIC can access some of the data, usually joined or aggregated, like just views that are ready to be analyzed. Finally, we have the external layer, which contains the views that we share with our external stakeholders. For instance, in our Climate-KIC website, if you want to have a look, we share a list of our innovation projects. And for our website, we use a third-party provider to manage it. And this is where they would access the data. So there's no data breach. We are in control of our data and we know who can access the data and what they can access. But the beauty of it is that when something changes at the ingestion layer, those changes are applied automatically across all the layers. And this can be done in two ways. First, in the case that there is a Talend job creating the data, the new data points or changed data will be automatically changed or added every time the data is updated because we schedule those Talend jobs to do so. So everything is automated. The other way is when we create views. So when the data is changed at the ingestion layer, the power of the views, instead of tables, is that they change as soon as the data is changing. That's great, although when we do not use view all the time, because when you have a lot of data, when we're talking about big data, it can become very cost consuming. So what we do in that case is that we create materialized views. And unlike a normal views, it is not a window in the database. Rather, it is a separate object holding query results and we refresh the data periodically. So for instance, if you were to update your data every hours, those materialized view will only update every hours, not every time you're looking at a view, because the views are like cascaded. So this is the most optimized way for us to query the data without consuming all your Snowflake credits, which increase the cost. Not that Snowflake is that expensive though. But yeah, this is how we structure the data in Snowflake. Now, I'm going to walk you through quickly because you don't need to know all the details, but what I want to emphasize is the power of Snowflake is that you can create as many users as you want in a very secure way. And it's quite easy to do this in the front end of Snowflake. But what you can also do is create roles. So a user must be attributed a role, and their role will decide which data they can access or not in Snowflake. So ideally, you would have a system where you would have a system admin role for your developers. They can access all the data because they're building the data architecture. However, anybody else, your analyst or externals, anybody else would have access to the consumption layer only and only see what they're meant to see. So in this specific example, what I wanted to show you is that because at Climate-KIC, we are spread across Europe, so we have different legal entities to manage our employees. So we would have a local finance team in Southern Europe and one in Poland and so on and so on. So, and each geography will make sure, for instance, that our employees get paid every month. So in that example, we have, let's call her Anna, and this will be Marco on the right side, the people/tools. So Anna is responsible of the southern staff, being Italy and Spain. So she has therefore access to a specific role, which is Mediterranean role. So she'll see only the Italian and Spanish financial data that she can access, right? However, Marco, which is based in Poland, it's a very Polish name, Marco, by the way. So he won't be able to see any of Anna's data. He will only see the Polish data. So everything is secure. We know exactly who has access to which data when. If Marco were to leave the company and Andrew replace Marco, then we just disable Marco's users. We create one for Andrew and we give Andrew the Poland role. And he can see exactly what Marco was able to see. So that's great with Snowflake. So I've talked a lot about how we clean the data. And as you all know, as a data scientist, we always spend like around 90% of our time cleaning the data and actually only 10% analyzing and doing some cool AI or machine learning or regular analysis. So what I want to talk to you now is what we have done at Climate-KIC with this clean and nice data. So I won't be able to show you everything because I have some confidential constraints, but I've done my best to represent what we've done. So first thing that we use a lot at Climate-KIC is our Tableau dashboards. And this is just a screenshot, but we regularly have partners applying for a grant to support their innovation projects that will help us to have a greener future. So we usually open our grants twice or 3 times a year and then go through what we call a portfolio process. So this process is to actually look through all of our current portfolio of activities as well as what we have done in the past and identify the gaps in our activities. So we then evaluate each proposal we're receiving and try to understand how they fit in our current portfolio. And we ask questions like, is it something that we've already been doing, or how this project would impact our portfolio, or where are we missing activities, and so on and so on. So in this very simple example, we have a list here of activities with different filters. We have here the type of activity, the country, and we can search by keyword, etc. And we can see the amount of funding that have been allocated to the specific projects and how they contributed to our impact goal. An impact goal it's a pathway defined to help us get on track with avoiding dangerous climate change. So those pathways are consistent with the United Nations Sustainable Development Goals, like that we set up in across the world in 2015, I think. In that case, in the first one, we have promote retrofit and decentralize energy. We have create grid resilient cities, accelerate clean urban mobilities, etc., and so on and so on. So if we were to click on this promote retrofit and decentralize energy, it will filter down the rest of the data for these specific impact goals. So this is one thing we do, and the other thing, to something that we recently done in our team as well, and to dig a little bit more in the data science space, is natural language processing, NLP. So an NLP has for aim to read, understand, and sort of make sense of the human language in a manner that is valuable for us, right? So in our case, what we wanted to do was to categorize our different innovation projects to better understand what they were doing, and more particularly for historical projects. For instance, is a project trying to recycle plastic, or are we trying to better use our resources, or what technology is it using? So we needed to really understand what those projects were doing by categorizing them, so we can group them together and have this view of, for example, of all of the projects that are recycling plastic. So what we did is that we worked on around 50, 70 projects and on their descriptions, and we categorize them by defining subjects and keywords. So a project would then have multiple keywords to define the projects, and those keywords would be grouped in subjects. So we use this data set as a training data set and created an algorithm to apply this logic on all of our other projects. So to do so, we use Spacey library in Python. And let me show you quickly how it looks like now. We created a dashboard. So you can see here like all the subjects, the projects, and the number of projects, and how it's contributed and how much money we gave to those specific projects. So let's say now I would like to have a look at waste, so projects that tackle waste. And when clicking on it, we can see that this subject, those are all the keywords that are categorizing, or defining this subject. So this narrowed down the list of projects that are tackling waste. And there are around 100 projects, and this is around 8.5 million funding. Now, if I want to have a look at plastic recycling only, it filters down again, and we're able to identify those projects and to work on that. Well, that's mainly it. That is all for today. If you liked it, please comment on our LinkedIn post and join the next Data Science Festival Lunch and Learn. But before that, it's now time to give you some space for your questions and comments. So I'll hand over back to you, David.
Perfect. I'm back. So hopefully you can hear me okay. Yes. Thank you very much for that, Amélie. It was really good to get that overview of how you guys have approached it. And we've actually had a few questions coming in, which is great to see. And I've got a couple of my own as well, which is always good at the end of a talk. So we'll jump through the questions. Just to mention to the guys watching, in the Q&A feature, there is actually the opportunity to upvote on questions as well. So if someone else has asked a question that you think is particularly interesting, you can give it a little upvote, and that'll bump it to the top of our list just to make sure that we get through it. So the first question we go to, it's from, I've said the upvote and now everything's jumping around right in front of me. We'll catch up. First question was from Anonymous. Curious about the fact you're using Power BI and Tableau. What do you think that Power BI provides that Tableau doesn't?
So we use Tableau more for an overview and to have one source of truth. It's more for senior management because it's well designed and you can do a lot of things. We use Power BI, which is more for the local team. I guess it's more for a cost perspective because rolling out Tableau to the whole organization it comes at a cost. So we have our Office 365 and Power BI is in our E5, Enterprise 5, it's all included. So everyone in the company has a Power BI license, so it's cost efficiency. But Power BI works also great. You can do some great visualization as well, and it's more self-service.
It's a shame. There's always a budget, isn't there? You have to think about these things. So that makes perfect sense. Next question there is from Connor Goddard. Did you consider any open source / free workflow orchestration tools such as Airflow?
I'll have to come back on that one. Yeah.
I think a lot of customers that we work with have a preference for Talend. Actually, I think it seems to do do what it says on the tin quite nicely, doesn't it? So
yeah, and it has some very nice feature, like some dynamic schemas, so it will automatically detect what format is in your database and apply this format in seconds. Mm-hmm. Whereas in some open source and free workflow, as you ask Connor, is more you have to do it for each data point, so it's more time consuming, which we didn't have much time at that point, but yeah.
Okay, cool, thank you very much. Question at the very top there from Lovkush. What is the difference between the curation step in Snowflake and the things that Talend is doing for you?
So Talend is operating in the curation layer. So Talend will take the data from the ingestion layer and perform some jobs, fit for purpose jobs, to curate and clean the data at the curation layer. So at the curation layer, we both use Talend to clean a lot of data and harmonize data. And we also use some pure SQL to aggregate, join, aggregate and join the data. So we use a combination of both at the curation layer. Fantastic. The Talend will just clean the data.
Makes sense. Thank you. Next question we have, again, it's from Connor actually. So Connor's asked some very good questions here actually. Do you apply any particular naming conventions to table schemas views in Snowflake to distinguish between the different layers, calculation versus consumption, etc.?
Yeah. So I've shown you the 5 layers we have: ingestion, curation, calculation, consumption, and external. So to us, those make sense. But within each data layer, which are databases, we have different schemas. So each schemas will be for specific data. So we will have finance schema, HR schema, or grant management schema, Salesforce schema at ingestion layer and across all those layers. And at the consumption schema, this is where we'll prepare the data for the analysis. So we will have a portfolio schema, which will contain our full portfolio. So data coming from different data sources. And yeah, this is where we'll shape the data to be ready to analyze. So yes, we do have some naming conventions that we apply across all those different layers.
Okay, fantastic. Talking about data quality, the question there at the top from Beza, how are data quality checks performed across different data formats, XML or relational or whatever? Have you got any tips if people are ingesting data from different formats in terms of how you keep an eye on quality?
Well, Talend is great to help you doing that because it will manage those different formats for you. And it will, so the way Snowflake works is more a relational database. So what Talend will do is, even you're not using a relational database, you can shape the data to make it relational database. And that's the way we used to structure our data. Then again, you can go through different ways. Mm-hmm. Data quality check, well, you have to dig into your data. There are many tips online on how to check your data. But I think as soon as you start visualizing your data and analyzing your data, this is when you can identify issue. So one of the big challenge we had was to make sure people were using the data and helping us curate the data. Because as soon as your end user starts using the data, they will understand better than business than we do as data architects or data analysts, etc. So this is where it works well together when you have these 360 views and everyone is owning the data and working on the data together.
Okay, that kind of answers one of the questions that was on my list actually. But in terms of getting business buy-in, when you're talking about data governance and you're putting these new systems in place. How did you find it in terms of having the buy-in from the business? Was it pretty good, or did you have to work quite hard to get that?
No, I think it was pretty good because we were in need of having a data architecture. The business was desperate to have one source of truth for the data and to make decisions based on our data. So it wasn't, I mean, it was not easy neither, but you always have to justify and explain what is good, what is bad, and why it's actually taking 6 months instead of 1 month, because you think that these extra steps of effort is actually worth it. So it's always about evaluating what is like quick and dirty, or what is taking a little bit longer, but actually more robust.
Yeah, doing things properly, eh? I like that. I like that. And do you think that you mentioned offering sort of self-service?
Yeah.
Do you think that really helped for the business to get that, buy-in, the fact that they could access the information they need and almost have some of that ownership?
Oh yeah, yes. And what they really appreciate was there's many aspects that are great. One is that we do not share data with an Excel file on email, for instance, so no data breach, almost, I think, I hope. And the other thing is that they can refresh the data anytime. So if tomorrow we have 3 new projects, they have the live data. So they do not need to come back to you and say, oh, do you have an updated data set? So this makes things so much easier.
Perfect.
And secure.
Thank you. Thank you. I'm actually going to skip your next question, Connor. Sorry, you've been very good. You've had a couple. We'll come to that at the end if you have one. Next question from Daniel Thompson. In terms of credentials within Snowflake, do you know if it's possible to sync credentials from another provider like Active Directory or something like that?
Well, I'm not sure about how you could have those credentials through your other provider, but what you can do is Snowflake is run a script, a SQL script with all the logging and the passwords, and you can put like a dummy password by default because you don't want to see people's passwords, right? Mm-hmm. So you could import that from another provider, depending on the format the other provider will provide it to you. But you can always find some tricks around, right? If you have the list of all your users in the other provider, you can create like a small script maybe in Excel, to have your specific SQL code and just launch the script in Snowflake. That's fairly quick. Okay,
fantastic. Thank you. Obviously, you've selected Talend and Snowflake as your preferred architecture. Did you compare any other products out there before you got to that decision?
Yes, we did. I was not fully part of this comparison because he was starting to get done before I joined the company. But we did compare them against other. So for Talend, there was Astera. Can't remember the other ones we had. We had a couple, Clover DX as well, which is quite good actually. So we compared Talend against other, and Snowflake as well. We compared against BigQuery, AWS, and all the big out there. And we had a great relationship with Snowflake, and it was actually cheaper for us to keep Snowflake. And the way we used it and the way we share data is so much easier with Snowflake. So that's also one of the reasons we decided to keep Snowflake.
Okay. Fantastic. Sounds good. Next question from George. While working with tools like Snowflake, Talend, Tableau, etc., what sort of programming languages are involved? Could you have replaced part of your workflow with custom programs like written in Java or C or whatever?
Well, I don't think so, no, because so Snowflake has quite nice user interface. So it's quite easy there. You don't really need to program apart from SQL. Talend, where we have our in-house data architect, Matt, which is really good. So he knows his stuff. So he knows probably how to program in Java because Talend is sort of Java and yeah. And well, Tableau is BI. But I think what we're looking at currently is doing more data science. So Python is what we're looking to use more. So the NLP was a start, but now we are going toward that direction, really analyzing our data.
Okay, fantastic. Thank you very much. Next question is from Noor. Good to see you on, Noor. how do you use data catalogs and data dictionaries? Are they created automatically with a tool, or is this a manual effort?
No, we have some data dictionaries coming from our systems, our grant management systems and Salesforce, and this is generated automatically. And then we had to do, of course, a manual process of mapping that data across our system. So in the data warehouse, where we have, as I said, specific fields that are the same, and then we need to decide who's the master of the data or not. So we did have half automated, and now it's all sorted. So yeah, it was half automated and half manual. There's always a bit of manual side, yeah.
Okay, thank you. Next question from Vitor. Can you tell us a bit more about the data formats you have in each layer of the data?
Yeah, sure. So for grant management system, we actually have a SQL database. It's a mirror database. So that would be a database. Well, Salesforce is pretty easy, it's connected directly. We do have some JSON files for our website. Yeah, I think with Talend, it doesn't really matter which format is ingested, because that's why Talend is a good product as well, because you can connect it to anything. Mm-hmm. So yeah, we have different formats, but never came across anything that we could not do.
Okay, fantastic. Thank you very much. I like the next question. It's a shame we haven't got someone's name next to this one, actually. Do you think that we in the tech industry have an extra responsibility to consider the environmental impact of our work?
Well, that would be great, yes. I think we do as human, not as a tech person. We all do as human to think about our environmental impact. And yeah, definitely, yes. And even more in tech, because you can do many things digital that can help support businesses. And yeah, I think there are many things that can be done with tech to tackle this big issue.
Okay, thank you very much. Next question from Michael. Have you had any use cases for streaming data?
What do you mean streaming data?
I'm guessing like Spark or something like that.
I'm not
Probably
sure.
not as relevant for finance and grants and that type of stuff, maybe.
Yeah, I'm not sure if I can answer that one. Sorry, I might have to come back to you, Michael.
Okay, that's cool. We'll hold you to that, Amélie. We'll be following up for emails from you.
Okay.
I'm going to skip down to Daniel's question next. You were talking about data governance and lineage. Was it a challenge to track data usage and governance, given that you have multiple vendor products as part of the chain of data delivery? Do you lose data lineage when it goes between products?
Well, I'm trying to think a little bit that question. Well, of course we had challenges to track the data, and I think one of our challenge was really to look forward, and we have a changing business all the time, because climate change is changing and we are changing because we are part of it. So our business is quite changing a lot of the time. So we were more concerned of building something that will be lasting in the long term. But the data, it's not really an issue that is coming from multiple sources. It's more a pain to like keep track of it and to make sure that we have the correct data. Yeah, I don't think we lost any data lineage. Yeah.
Okay, thank you very much. This is like, I'm a bit aware actually, the speakers finish their talk and then I just absolutely pepper them with questions. So if it's a bit intense, tell me to calm down a little bit. It's fine, it's fine. We've got a question from Alessandro. So again, good to see you online, Alessandro. I hope you're doing well. How do you approach master data management?
Good one. Well, for that one, we have to gather the teams usually. So I have a very specific example, but we have some partners' data that we are managing in different systems, our grant management system and in our CRM. And we had some data conflict because same data, different values, right? So we had to put in place some processes to make sure which system is mastering the data and which data should we trust. And in that case, we had to get the team together, make a smart decision together, and all stick to it. And I think that works pretty well when everyone is involved and is happy with the solution. It's always about communication as well.
Fantastic. Yeah, that's the hard part for us techies, isn't it? Communicating.
Yeah.
Next question. Again, it may be one to answer now, it may be one to follow up with afterwards, I don't know. But Anonymous has asked, what are the different ways that you can include Power BI in machine learning projects?
Well, I gave the example of the natural language processing that we did, and our way was to visualize a result in a Power BI dashboard or in a Tableau dashboard. So I guess whenever you do machine learning projects, it's not about just building the algorithm, it's about using the data that you've been creating. Yeah. So I always like to think that whatever we are creating, whatever we are putting together, we still need to visualize it and make it useful for the end user. Yeah. Because if no one is using your work, then there's almost no point of doing it. Yeah. So, yeah.
Makes sense. We've got two questions left from Ryan. We may have already touched on this a little bit, but clearly, obviously, you're very happy with Snowflake. What led you to the decision of choosing Snowflake? And I know we have touched on that a little bit before.
I think it's managed really well, the users' permissions and roles. This is something that we really appreciated, to know who can access what, and it's pretty easy to give or revoke access to some specific data. So that has been a revelation for us. It was very good because we are around 300 people in our organization. So you sort of have to think how to manage that. And from a cost perspective, it was very good for us. It's built on top of AWS actually. So it's very fast product, everything in the cloud. So if your laptop dies tomorrow and you still have to work, you can do it from your personal laptop. You just log in this cloud-based platform. Perfect. So yeah, that was really good for us.
Sounds good. Sold. We've got one question left from Sana. And it's a good question to finish with, actually. There's a little bit to this. So you could probably spend about half an hour talking about how to do this one. But Sana was asking, do you have any tips on how to go from messy systems and architecture to really getting on top of things using Talend and Snowflake? What did you do to approach that? Or have you got any tips on where to start?
Patience.
Yeah,
I think you need to be really patient and try to reassure the people that actually are craving for that clean data. It takes time, it takes effort, it takes some understanding of the data as well. Sometimes it's not just straightforward. So I think I would try, I would say to you, Dana, that you should sort of try to prioritize which mess you want to sort out first. What is more important for the business, what will bring most value for the business, which is what we did at Climate-KIC. We started with what was more important for us, what we needed critically to keep the business going. So, and I think you need a lot of patience and hard work.
Perfect. There's no easy way, basically. You've got to start. Final question now. I'll answer this one. Missed part of the recording. All of the presentations from the Data Science Festival end up on our YouTube channel. So please do check that out. So, man, that was absolutely fantastic, Amélie. Really good fun. We flew through, I think, about 18 questions at the end there as well. So we definitely made you work with the Q&A. Hopefully you enjoyed it. How was that for you?
Yeah, that was great. I'm glad so many people joined. Thank you very much all for joining. And yeah, anytime. If you have any other question as well, feel free to contact me.
Find her on LinkedIn and make sure you all go say thank you. It's perfect. So we'll end things there until next week. Thank you very much once again, Amélie. And yeah, we'll see you all soon. So,
great. Thank you.
Bye-bye.
Bye.